Okay, this is problem number 3 from the June 12 exam. The problem reads the quotient of 8x to the 5th minus 2x to the 4th plus 4x to the 3rd minus 6x squared, all divided by 2x squared, is 16x to the 7th minus 4x to the 6th plus 8x to the 5th minus 12x to the 4th. I'm not going to read all the options for the answers right now, but I'm going to show you how to do this problem. Let me make it a little bigger as well. Okay, so we're doing group division. Okay, so when we're dividing by 2x squared, we are dividing every single part of this quantity by 2x squared. Teachers typically break this up and do it one of two ways. Some teachers will write every part divided by the 2x squared. So some teachers will write 8x to the 5th over 2x squared minus 2x to the 4th over 2x squared plus 4x to the 3rd over 2x squared minus 6x squared over 2x squared. Other teachers will write it out 8x to the 5th minus 2x to the 4th plus 4x to the 3rd minus 6x squared all over 2x squared. And then they'll say, remember, you have to divide this by this. And then you have to divide this by this. And then you have to divide this by this. So all of them have to be divided by the 2x squared. I am going to stick to the second, the first thing I wrote right here, because it's easier for me to do all the terms with you. All right, so once we've done this out, the only reason we can, once we've done this out, we want to look at each term and do each term individually. I'm going to look at 8x to the 5th minus 2x squared. I'm going to take a little bit of time going through this so people can remember the rules for exponents. And then I'll spend less time on the next terms. So if I look at 8x to the 5th divided by 2x squared, you may remember your rules for your exponents, or you may not. If you don't remember your rules for your exponents, you can just write this all out. 8x to the 5th is 8 times x times x times x times x times x. X to the 5th means x multiplied by itself 5 times. Similarly, 2x squared is the same thing as 2 times x multiplied by itself twice. Now when we do this, we can look and we can see that these x divide out to 1, these x divide out to 1, and 8 divided by 2, that divides out to 4. So I really am writing 4 times 1 times 1 times x 3 times. 4 times 1 times 1 is the same thing as 4 by the multiplicative identity property. X times x times x is x to the 3rd. So what we've done is we've determined that 8x to the 5th divided by 2x squared is the same thing as 4x to the 3rd. If you remember your exponent properties, well, if you look at the 8 by 2, you get 4. And then if you remember your exponents properties, we have x to the 5th divided by x to the 2nd, we get x to the 3rd. When we divide exponents, you can see that 5 minus 2 gives me 3. So we can also remember that when we have exponents and we're dividing, you subtract the exponents. This is only true when you have the same base, so the x's have to match. Personally, I like to do it out first to make sure that I know what I'm doing, but if I become comfortable with this, I will just subtract the exponents. So we know from our work that the first term is 4x to the third. Being smart test takers, we can eliminate the first two answers based on that work alone. Okay, so then going down to the next term, we have 2x to the fourth minus, we have 2x to the fourth over 2x squared. Okay, again, I'm going to do it out the long way, and then I'm going to do the short way, and then I'll just do the rest the short way. So this is the same thing as 2 times x 4 times divided by 2 times x 2 times. Okay, so 2 divided by 2 is 1, x divided by x is 1, x divided by x is 1. So this simplifies to 1 times 1 times 1 times x times x. By the multiplicative identity, 1 times any number is itself, so this is going to be the same thing as 1 times x, which is the same thing as 1x squared, which, again, by the multiplicative identity is just x squared. So the long way, I get this. If I do it the short way, if I do 2x to the fourth minus 2x squared, 2 divided by 2 is 1. I have the same bases here, so I can subtract my exponents. So I get x squared, 4 minus 2. 4 minus 2 is 2. And then again, by the multiplicative identity, 1 times x squared is x squared. So my second term up here is going to be minus x squared. All right, let's just finish the next two terms using our exponent properties and our division. So if I look at the third term, I know that 4 divided by 2 is 2. I know that I have the same base, so I can subtract the exponents when I'm dividing. So I know that 3 minus 2 is 1, so this is 2x to the 1, which is the same thing as 2x, because x to the 1 is x multiplied by itself one time, so it's the same thing as x. So I'm just going to erase this, and I'm going to erase this one. Finally, using our exponent properties, we have 6 divided by 2. I'm going to bring the minus along. We have 6 divided by 2, which is 3. X squared divided by x squared. That's going to be x to the 0. All right. This one I think that people get confused with a lot, so I'm going to do this out longhand. If I have, I'm going to go down here and write in red. If I have x squared divided by x squared, that's the same thing as x times x divided by x times x. These divide. When you divide any number by itself, it's 1. Divide any number by itself, it's 1. So this is equal to 1 times 1, which is equal to 1. Many students get confused, and they think that x divided by x is 0. That is not the case. It's a 1, and that 1 will disappear in many cases using the multiplicative identity property. Let me write that out so you can hear what I'm saying. I'm saying multiplicative identity. Okay, so I know that x squared divided by x squared is just 1. Okay, so I also know that x squared divided by x squared, 2 minus 2 is 0, is the same thing as x to the 0. So I'm going to replace this x to the 0 here by a 1. So this can be 3 times 1 by the multiplicative identity. 3 times 1 is the same thing as 3, so I'm just going to make that a 3. Now if we go up here, we have two options, 4x to the third minus x squared plus 2x minus 3. And so number 4 looks like our proper answer. And you can see people who designed this test clearly put in number 3 to test if you knew that x squared divided by x squared was 1. 1 down here, and not x. So again, for me, breaking it down into the long division sometimes helps me figure out the right answer. Okay, so this is the right answer. Now I'm going to show you in one more thing to help you verify whether or not you got the right answer. Again, I'm going to bring up my graphing calculator over there on the side. And if I want to check if two expressions are the same, I can put them in my graphing calculator and see if they're the same. So I want to put my problem here into the graphing calculator. Okay, and then I want to put my answer into the graphing calculator and see if I got the same answer. All right, it's very important that you realize that this long division is a grouping symbol, which means I need to put parentheses around the top and the bottom when I put this in my graphing calculator. So again, here's my graphing calculator. I'm going to go to the y equals key. I'm going to put in parentheses, 8x to the 5th, minus 2x, 4th, plus 4x to the 3rd, minus 6x squared, I'm going to close my parentheses, and I'm going to divide that by parentheses 2x squared. Okay, so that's my, this is from the question. Oops, disappeared. Now I want to put in y2 the answer. So I'm going to put in, for y2, I'm going to put in 4x to the 3rd minus x squared plus 2x minus 3. Okay, if these two, the y1 and y2 are the same, are different expressions representing the same expression, then they should be exactly the same. That means when I look at the graph, the table, if I do second table, all of the numbers should be matching, okay? The only place I don't have a matching number is this error. But I have 229, 220, 102, 102, 245, 245, 482. This looks like it matches really well. The thing that is really throwing me off is the error when x is 0. Why is there an error when x is 0 in the first expression? If you look at the first expression, I'm going to do a whole bunch of erasing here. If you look at the first expression, you have 8x to the 5th minus 2x to the 4th minus 4x to the 3rd minus 6x squared, this is plus, all over 2x squared. If I set x equals to 0 here, and I plug it in, I'm going to get 8 times 0 to the 5th minus 2 times 0 to the 4th plus 4 times 0 to the 3rd minus 6 times 0 squared, all over 2 times 0 squared. All of these turn out to be 0. So 8 times 0 to the 5th is 0. 2 times 0 to the 4th is 0. 4 times 0 to the 3rd is 0. 6 times 0 to the 2nd is 0. 2 times 0 squared is 0. I have a plus, a minus, a minus. So I have a minus, plus, plus. A minus, a plus, and a minus. 0 minus 0 is 0. Plus 0, 0. Minus 0 is 0. So I get 0 over 0. And I can't divide 0 into 0 parts. Okay, so this is, expression is undefined. Okay, later on we'll do some problems where we have try to determine when expressions are undefined. But if you put an expression in your calculator, it'll show you when it's undefined. So what I'm saying is the first equation is undefined at 0 because it's got the x in the denominator The fourth equation, which is the correct answer, is not undefined at 0 because it doesn't have a denominator. Nothing is there. Which is why these two expressions do not match at x is equal to 0. Everywhere else, no matter where I go, they match. So that shows me that they are almost equivalent. They are equivalent expressions. Okay, so this topic is called dividing polynomials. If you need more practice dividing polynomials, find this expression on the website and go to that area, and there will be a lesson and practice problems on dividing polynomials.